Hello students, today we will discuss about dispersive power. Dispersive power is basically the ability of the instrument to bend more, to bend rays more. That means if I consider a prism and let a white light pass through it, it will split the white light into its constituent colors, and those constituent colors starting from V to R, violet, indigo, blue, green, yellow, orange and red, are not deviated or bent to the same degree. Violet is bent the most, red the least. So in one prism which is made up of one type of glass, say ground glass, if I have another prism made up of flint glass, then this particular white light will get dispersed differently. That means the colors are deviated through different angles for the same color. So therefore, dispersive power is a property of the material of the prism. If you change the material, the ability to bend more will change. That means if the prism has more dispersive power, then it will bend more, or the angular separation between the two extreme colors will be more. Okay, it is basically the measure of degree of angular separation between the two extreme colors. Okay, now we'll define it. So dispersive power, I'll use the symbol omega. Omega stands for dispersive power. So dispersive power is the ratio of angular dispersion divided by deviation due to mean color. Deviation due to mean color. So now angular dispersion, we have already found that the angular dispersion is delta V minus delta R. So delta V minus delta R, it is a difference uh, between the two, angular separation between the two extreme colors. Okay, because if I consider a prism over here, so basically angular dispersion is this angle. This is delta V minus delta R. This is angular dispersion. The angle through which the colors are spreading is the angle between the two extreme colors. Now divided by mean color. Generally, for white light, the yellow color is called the mean color. Okay, so yellow is called the mean color. So yellow is the mean color. Or you can also take the mean of the deviations produced by the two extreme colors. So that also we can write. That is, we will do that in the next page. So angular dispersive power is delta like this. This is yellow, violet, red. V stands for violet, red and yellow. Okay, now we know that delta is A into mu minus 1. This is valid for thin prism. If this is valid for thin prism and we are finding the dispersive power for thin prism, then we can approximate it to, for the violet you can write delta V equals to A mu V minus 1. The angle of the prism is not going to change. For red color it is so this way you will write for different colors. This is for violet. This is for a yellow color. Now, if I substitute this over here, I'll have if I take A common, then I'll cancel it out, and what is left is this is the expression for dispersive power for white light. I mean dispersive power of a prism when we use white light. Mu V mu minus mu R divided by. If I use any two other colors, the combination of three colors, then those three colors will be separated while passing through the prism, and those two extreme colors that is formed. It may be green or yellow or blue. I can take those two extreme colors. Then here, so I will put that value here. Suppose this is blue and this blue and green, like so. I'll substitute this here. Whichever color that are the extreme colors, that I will put here. Suppose the extreme colors is not violet or red or any two other colors, then I will put those two extreme colors over here in these two places. The colors which is bent most is refractive index will be written first, and then for this color which is bent more has a higher refractive index. So therefore this is positive, and therefore this minus 1 will write here. So this is the expression for dispersive power. As you can see here, that in case of angular dispersion, so it is basically the angle between the two extreme colors. So therefore it has radian unit or degree. But in this case, dispersive power has no unit and no dimension, because it is a ratio of the refractive indexes, or from here also it is a ratio of the two angles. So no unit. Okay. Now this formula will be very handy when we'll be dealing with the prism. Next is how can we write this if I don't want to write yellow color, then which other color or what else I can write. As I told you, it is about the two extreme colors 1 and 2. Okay, and the mean color may not necessarily be yellow. If it is given, is okay. In case of white light you can take, but then if it is not given, then we'll take the mean of this. Delta mean is delta 1 plus delta 2 divided by 2. We'll take the average of the two deviations produced. Okay, this is your delta 1 and this is your delta 2. Then we will take the average of that. That will also do. For white light, these two are violet and red. So therefore for white light I can write this is delta for mean color. This is divided by 2. I will write. So if I do that, then dispersive power will be delta V. This is how we define this. This is how we write the dispersive power. Now it basically depends on material and also the medium surrounding the medium which disperses it. For example, if I talk about prism, then the prism kept in air and the prism kept in water. Prism kept in air and water. In both the cases, even if the same white light is used, the dispersive power will be different because this value will change, the refractive index will change, as we have seen that the dispersive power is coming out to be mu v minus mu r by mu y minus 1. So here the refractive index for violet light or red light, for air and for when it is through air and when through water, it will be different. So if I dip a prism in water, then its dispersive power will change. Okay, if a prism is dispersed in water, its dispersive power will change. Okay, so this is all about your dispersive power. No unit, no dimension, depends on the medium and on the material. If the colors are bent more, then it has higher dispersive power. Or if the angular separation between two colors are more, suppose in one prism the angular separation between two extreme colors are like this much angle, and in other it is more, then that means the second prism has the ability to disperse the colors more, so it has higher dispersive power. Higher dispersive power means more angular separation between the extreme colors. Okay, thank you.